Okay, start recording the video. Okay, so let's look at the question. Okay, this is an important question because every year in the examination, there's one such question, 25 marks in the exam. So a lot of marks there. Okay, so what we're going to do is find the great circle distance. So great circle distance, so what is that? Okay, great circle distance, what is that? Yeah. And the initial cost, okay, what is that? Actually, from the point A to point B, all right? Two position there, give you position from point A to point B. Okay, so in a normal bearing question, we will just write, okay, bearing question, right? So basically, if I want to draw a bearing question, okay, so normally you put a North Pole there, and then this is point A, and then they want to know what is the initial cost, what's the cost, okay, what is actually the cost from A to B. Okay, A is actually 51 degree, 10 minutes, okay, 51 degree, 10 minutes, okay. A is this point, and 10 degree west, this point here, west, right, in north here, and B is another point, 52 degree going north, okay, 55 west. So you're going to west, right? So actually B is somewhere here, so you're going to be okay a bit higher. So B is this one, okay. So if you want to draw B, maybe B is somewhere here, B here. Okay, so 52 degree north, you're going north, right? From 51, 52, and then direction is going west. So this is actually what is the initial cost? Initial cost is a direction measure from here, North Pole. This is called initial cost. Okay, this if you do it as a bearing question, it looks something like this. Okay, but we have better solution. This is actually a great circle, so it's bigger triangle question. Okay, if you try to draw it, then you should get something like this. So you have great circle A. Okay, let me use the red color. So you have point A here, going to point B on top. Okay, going northwest here, B. And there's also a North Pole, P. Okay, so you just know that the North Pole is already on the North Pole, so this is actually 51 degree, 10 minutes north, and this is 10 degree west location. This is 52 degree north, 55 degree west. Okay, if you draw a triangle, make sure that you draw a spherical triangle. Basically, it's not straight line, basically they are all curved. So what does it mean? You want to understand this problem. So let me go back and draw the sphere for you. Okay, so I'm going to go back and draw a sphere for you here. So this is actually a sphere of Earth. So Earth there is a equator. So equator 0 degree north. Okay, 0 degree north, right? Equator. There's a pole there, North Pole. Okay, so then let's see, I draw a meridian. Let's say this is actually 10 degree west. The South Pole here now. So this is actually 10 degree west. Okay, and the point A is 51 degree north. It's an A here. 51 degree north, 10 degree west, right? Where is this? So suppose this is center of the Earth. The center of the C here, we will call it C here, center of the Earth. And then what does it mean is that this angle is 51 degree 10 minutes. Okay, 51 degree 10 minutes. This is angle. Okay, measure from the equator, go up 51, 10 minutes is for the point A. Then where is point B there? So you're going to north again and then going westwards. So let's say this is, I think I want to draw it farther away so they can see better. So suppose this is where the B is now. Draw a meridian. So this square circle is 55 degree west. Okay, it actually moved westward, and then this equator again, and then B is somewhere high up here, and the latitude is 52 degree. So from here to here, this is 52 degree. So I'm actually finding the great circle distance from A to B. So you can draw a great circle. So great circle, let's say this is A to B now. Okay, so you can draw the great circle. Okay, this circle pass through origin, pass to the center of the Earth, right? This great circle. Okay, so I want to measure the distance. First thing, where's the distance from A to B? Okay, along the great circle. So this question, the first part, find the great circle distance, all right? Find the great circle distance, I use the yellow color. So let me change the yellow color first. Okay, so let me change the yellow color first. So I want great circle distance. So this is great circle distance I want to find. Okay, then I also want to find the initial course, the ship heading to. So the North Pole in this case is going to end now. So this is actually direction of the North Pole, the direction of the North Pole, right? The initial course basically is, let me use a blue color one, this angle from the North Pole measure all the way to here. This initial course alpha. Okay, directly from the North Pole, right? So this toward the North Pole, then you measure from the direction, go to the direction of the ship heading. That is called the initial course. Okay, so in terms of diagram, this is a usual bearing diagram. Okay, the usual bearing diagram, but we need this for your understanding, how everything corresponds. This initial bearing diagram. But in terms of planet Earth, then the diagram is supposed to be looks something like this. Okay, alpha is the initial cost. Okay, alpha is the initial cost, and the distance AB is the yellow part here. So I don't need this bearing diagram anymore. So I'll ignore this bearing diagram now. I'll use it when I necessary. Okay, so okay, maybe I stay with it first. So now let's do some calculation. Okay, how to do calculation? I can calculate something called the co-latitude first. Co-latitude or A first. Okay, so I write co-latitude A now. Co-latitude of A. So what doesn't mean the co-latitude of A? Basically, is 90 degree minus latitude, right? Latitude of A, yeah? Okay, which is actually PA. Okay, from P to A. The distance from P to A. So you know that this angle from the center to the Earth, this is 90 degree. Okay, so PA is the angle between, you can see from there now, this angle is 90 minus 51 degree, 10 minutes. So you can find that this equal 38 degree, 15 minutes. So what you find is actually this distance. This distance here is PA. In the angle, okay, we calculate difference between 90 degree and 51 degree 10 minutes. This is the distance PA, called co-latitude of A, PA. Okay, you can also find the co-latitude of B. So you can write down co-latitude of B, which is PB now. How to find PB? Take the 90 degree minus latitude of B, 52 degree. So you find that this is equal to 38 degree. Okay, this is the co-latitude of B now. So I can put here this distance, co-latitude B. Okay. Then do you know what is the angle P? Angle at a point P. Okay. Angle point P is, what is this angle actually? The difference between the longitude now. Okay. Distance between longitude P here. So angle P, the shift move from 10 degree to 55 degree, right? So actually you can write down here longitude of A. Okay, longitude of A is 10 degree west, and then longitude of B, okay, longitude of B now is 55 degree west. So the difference, which is called the D long, okay, D long is the difference there, is the angle P is equal to 55 minus 10, difference is 10 degree, 45 degree, all right, sorry. So this is actually 45 degree. Okay, just take 55 minus 10 is 45 degree. Okay, so angle P is 45 degree. So let's take a picture of this thing. Then we go on to look at spherical triangle. Okay, let's take a picture of this thing first. DNS 2192. Take a picture of this thing. Okay, so this is how you analyze the problem and then transfer this picture to the spherical triangle. Okay, so go back to this question now. Okay, PA is 38 degrees. Okay, PA is 38 degrees, so here PA is 38 degrees and 50 minutes. Okay, the length PA, the length of PB is 38 degrees. Transfer. The angle is 45 degrees. So the great circle distance is this distance we're looking for now. Okay, great circle distance. So obviously, what is the law I'm going to use? Is use the spherical triangle cosine law. So what is that law looks like? You still remember? So this is during a quiz because it's open book. So all the formula is available for you. It's open book. You can check, right? So I want to find great circle distance AB, right? So AB is actually the side P here. It's small p here. Okay, so this is small p here. Small p here. So don't need so long. Small p. So I can do cosine law, right? For great circle distance, sine find AB. Okay, actually find AB here. So we can see cosine of P, small p here, equal to okay, cosine of P. Again, got problem with this one. I want a short one. Okay, cosine P is equal to, okay, this side is actually side B here. This side is actually side A here. So we can use cosine of A cosine of B plus sine of A sine of B, then cosine of P, angle P. Okay, this is the law of cosine. So our spherical triangle. Okay, so I put in the answer for A. A is 38 degrees, and yeah, there's an A here, 38 degrees. B is 38 degrees also, but 15 minutes, right? Then sine of A, 38 degrees. Sine of B is 38 degrees, 50 minutes. Then cosine of 45 degrees. Okay, after you transfer all the information. Okay, so then you press calculator. You find cosine P equal to 0.886821368. So don't need so many decimal places. You don't need to write down so many places. But then you can find out what is P now. So P, the side P now, is equal to cosine inverse of this thing, or whatever answer, right? So this is equal to, and 27 degree 52 minutes. Okay, so this is not really, it's 27 minutes, so it's not this one. Okay, 27.52 degree. So they only convert the minute just in terms of degree will do. Okay, 57.52 degree. So there is a great circle distance for A to B, but the answer gives you is in nautical miles. Okay, the answer given you the distance is 1651 nautical miles. So how do you convert this to nautical miles? Okay, you can use the great circle distance, which is, so the great circle distance is actually we actually usually in degree a minute, right? So the great circle distance is the degree a minute here, but you can do this every minute. So 27.52. Okay, what you do is multiply by 60. Okay, centered. You want to convert to nautical miles. Okay, 1 degree will give you 60 nautical miles. Okay, basically, it's 1 degree on Earth is equal to 60 nautical miles. Okay, 1 degree on Earth is equal to 60 nautical miles. So you multiply by 60, and then you'll get 1651.41 minutes. So anyway, it's 1651 nautical miles. Okay, so okay, just multiply, right? So all right, so this will give you the quick circle distance between A and B. So the method to convert the nautical miles multiply by 60. Okay, so in case you don't know, now is this, all right? Multiply by 60. So okay, when I send this to you, you'll answer the first part of the question already. Okay, the next thing, I want to find the initial cost of the ship from A, right? Initial cost. So initial cost is where you can see the diagram. Initial cost of the ship is actually this angle. Okay, initial cost of the ship is actually this angle. I come and use a blue color one. Let me change it to green color. Okay, so green color here. Okay, I'll come to okay, hopefully work now. Okay, green color, initial cost. So in this case, to find the initial cost, so this is toward the North Pole. Okay, you look at the situation again. This is the direction towards the North Pole. Then the ship direction is actually the initial pole. Okay, the direction you're looking for is this angle to North Pole all the way to here. So you need to find the angle A now. Okay, angle A in a spherical triangle. Then you can find the bearing of the initial direction is called alpha here. So let's move on and copy this page and to copy this page first. Then I use it to move on to the next page here. Okay. Understanding what we are want to find out is the initial cost. So I'm going to rewrite this now. I did. No, I don't want this one. So I selection tool. I want to find initial cost. Okay. Last thing I'm going to find initial cost. Find the initial cost at A alpha. Okay, we cannot find alpha directly, but I can find angle first, right? So find A first. So okay, I want to find A here. So this is actually the side A here. This is side B here. Okay, so you have it there already. So I can use the lower cosine. So lower cosine, let's see, just erase this one. Just now we know P, we have found the answer already. Okay, P is 27 degree, 27 degree, 27.52 degree. Okay, don't need minute here. 27.52. Okay, so you make use of this to find the angle A. So make use of this to find angle here. So you can say, let's say, I know this side here, I know this side here. So I don't know, I can use the cosine rule. Okay, cosine rule is actually this side here and the corresponding angle. Okay, so I can find, okay, cosine A here. So cosine rule, so okay, I have cosine A equal to cosine, two sides is cosine P and B. Okay, P cosine B plus sine P sine B, then cosine angle A. So you have to rearrange them so that you can find angle A now. So cosine A minus cosine P minus times cosine B here, and then you divide by sine P sine B, and this is your cosine A. So plug in all the number inside there. So this is cosine A. A is 38 degree minus cosine P. P is 27.52 degree. And then cosine B. Cosine B is 38 degree. Okay, divided by sine 27.52 degree for P, and then sine of 38 degree. And this is cosine A here. So from here, you get cosine A is equal to 0.335 40 2945. Okay, doesn't matter write so much. just A go cosine the answer. Wherever you have just now, you find that it's 70.40 degree. Okay, after you press calculator, you find that A is 70.40 degree. So what is the bearing now? So okay, you can see the diagram of the bearing inside there. So the bearing initial cost now. So great circle cost at A is equal to, let me raise up a little bit here. So maybe I raise this up a little bit here. Okay, sorry, just let me. Good. Okay, so let me erase this one for angle A. So you can raise up this. Okay. Okay, so from here, let me, what is the direction now? The cos. So I know the great circle cos at A is equal to just 360 minus 70.40 degree, and find that this is about 290 degree true bearing. Okay, so this is actually 290 here. Okay, this 290 here. Okay, as indicated in the answer. So I can WhatsApp it to you. Okay, so the whole picture is actually understanding the problem. Okay, then you transfer all the information into spherical triangle. Now you can actually solve the problem using the sine law. The sine law, unfortunately, it will give you two possible answers, and then you have to figure out which one is correct. If you use the cosine law, you have no issue like this. It only give you one answer. Okay, so that's why people usually prefer the cosine law, because you definitely get only one answer. The sine law usually got two different answers. Then you have to decide which one is correct. Okay, so this is actually the initial picture of showing you where the ship heading. So you have to know the direction. Okay, it's going in the northwest direction. Okay, northwest direction, so angle should be more than 270 already. Okay, northwest direction. So you can see that everything is tabby in this diagram. Okay, so I move on to example 11. There is no issue. Okay, example 11 now. Okay. Okay, example 11, a vessel steer westward. So they tell you that you go to the west early, right? So this one actually going to the west. Okay. Along the circle from A, 20 degree, 25 degree, now 120 west, this location of the point A. So this is location of point A to a point B, we don't know. Okay, altitude of B is 58 degree north, so you know that it's going to the north again. Okay, west, northwest, okay, going to the northwest direction. And the difference of longitude between A and B is equal to great circle distance traveled by the vessel. So this is important information. The difference of longitude between A and B is equal to the great circle distance traveled by the vessel. Okay, this is important information telling you how to measure the difference between the longitude and latitude. Okay, so want to find the longitude of arrival and final cost. There are two things we want to find. Okay, the longitude arrival and the final cost. So in this case, where is the situation in point A, and the ship is at point A, is moving to the northwest. So basically, you have a point. If you draw the north pole, the usual bearing question, if you have a usual bearing question, okay. So I want to find out what is the bearing at B. Okay, so a bit difficult to draw because usually you have A here. If the ship move northwest, okay, northwest, so northwest in this direction now, to point B. Okay, the shift northwest now to point B, and then where is the final course? Okay, the ship, where is the ship directed? Okay, the ship may be still in the direction of northwest. Okay, so what is the final course? Okay, the ship may be so the ship may be still in the direction northwest here. Okay, no, it's similar direction now. So need not be like that. So maybe I just anyhow draw first. I don't know what its direction look like. So maybe this is the direction of ship here. Okay, when you move the point already, the ship will be the different direction already because it travel along the great circle. Okay, because travel along the circle. So I want to find the final cost bearing here. So final cost is actually bearing here this one. Beta. Okay, beta is the final cost. What is this? Of course, this is not a very good diagram. The better diagram is draw a spherical triangle. Okay, so let me show you what is happening in the Earth diagram. Okay, so I'm going to draw the Earth diagram now. This is example 10. So I'm going to draw planet Earth. This is equator. Equator means 0 degree north, right? Or west, doesn't matter. Okay, so the point A is somewhere here, let's see the North Pole here. Let's draw the location of A. So, okay, location of A is somewhere like this. So this is the meridian. The ship is at this line as 120 degrees west. Okay, from the diagram, right? A is 120 degrees west. And latitude is 25 north. So you have to draw the center of the earth here. And this is 25 degrees for the point A. Okay, the location of A is 25 degrees north, 120 degrees west. And the ship is moving toward west and north. So where is another point now? There's another point B. So the point somewhere is B now, high up. And this time we don't know. Okay, we're going to find out. We don't know, right? And the center of the earth, this angle is 58 degrees. So the great circle distance from A to B is this circle here. So draw a great circle. Okay, so they didn't ask you the great circle distance, but you need to know that also. So this is a diagram illustrated to here. So you can transfer this triangle to the next page first. Let me draw the triangle for you. So the triangle looks something like this. You have a point A, towards point B, high up here. Here a P. Okay, so this big triangle it's not a great triangle, so I mean I can draw it a bit more curved. Okay, a bit more curved. Okay, so I got this one. Okay, then let's try to figure out what is this. The angle P is the same as this long distance great circle distance small p. Okay, so this big circle, big P and small p are the same because you say that the difference in longitude between A and B now is the same as great circle distance between by the vessel, right? So this is what it is. Now I go back to the information. So this is yeah. So first thing you find out what is PA first. Can you find PA first? Okay, PA. Okay, this is going to North Pole. We know the angle is 90 degrees. So North Pole to the center is 90 degrees, right? So PA is 90 degrees minus 25 degrees. Okay, PA is 90 degrees minus 25 degrees, and you get this 65 degrees. PA. So you know, okay, what is this distance now? PA, 65 degrees. So this angle here is 65 degree. Okay, then what is PB now? So PB, distance between North Pole and B, is 90 degree minus 58 degree and this is actually 32 degree. All right, and this is a PB now. PB, this one. Okay, 32 degree. And we are given that the upward circle distance is small p here. This is a big P here, angle P. This big P, the small p is quick circle distance here. So quick circle distance is equal to the difference between longitude here is equal to d long. So they get small p here is called the big P. Now these are the information. Okay, then you can transfer this diagram to the next one. Right? Before I go back, maybe I just take this picture. Send to you now. Okay, so let's draw it. Okay, so I know PB is 32 degree. This is 32 degree. PA is 65 degree. Okay, so I can use the law of cosine to find out this. Okay, I can use cosine P there. So this is side A, opposite A. This is side B, opposite B now. So I can use cosine P here. Okay, I don't know the angle P. But anyway, I'm going to find out here. So using the law of cosine, we can write down cosine of P here, cosine of angle, no, side P here is equal to cosine of A cosine of B plus sine of A sine of B sine capital P. But we know capital P and small p are the same. So we can change this to anyway, change it to capital P now, right? It's the same. So now you see what you get now is actually cosine P is cosine of A is 32 degree, B is 55 degree plus sine 32 degree sine 65 degree, then cosine P. Now both of them have the same cosine P, the same angle here. So let's put them together, this one and this one together, right? I can put them together. So that means that I have cosine P, okay, minus sine 32 degree sine 65 degree cosine P equal to cosine 32 degree cosine 65 degree. And this cosine P are similar term. So put them together become cosine P 1 minus sine 32 degree sine 65 degree equal to cosine 32 degree cosine 65 degree. So I can find cosine P now. So cosine P is equal to cosine 32 degree cosine 65 degree over 1 minus sine 32 degree sine 65 degree. So
Sir,
first, yes.
why you want minus sign thing?
Which one? 1 minus
After cos, yeah. Why
okay.
1?
Why? Because this is actually time 1, right? This is actually 1.
Oh, okay.
Yeah.
Okay.
Okay, this is 1 here. So it's just 1 minus this thing. So I don't show my this out. I just write our answer. Yeah, press calculator. You find that okay, P is eventually 46 degree 24 minutes. Okay, so this means that this P is 46 degree 24 minutes. So what does it mean? Where is the longitude of B now? Okay, longitude of B. Okay, this is actually A is at 120 degree west. The ship going toward west. Okay, continue to go toward west. So where is this one now? It's actually go to the west, right? So this line, the passing to this one is how much now? So you going to west, you keep on increasing the angle, right? It's 120 continuing to west. So this one should be longitude of B now. It's actually starting from 120 west. You get another 46 degree 24 minutes west, right? Westward, right? You go to the west. So that's why you get 166 degree 24 minutes west. So this is the longitude of B. Because you're going to the west direction, right? So going to the west direction. So when the more you go west, the angle keep on increasing, right? So in this case, it's actually 166 now. Okay, that means that the direction in this picture here, where is it now? Yeah. So this line is 166 degree 24 minutes. So the ship move from A to B actually to increase the longitude. Okay, so to go back to this calculation. Okay, so this is actually this answer the first part, longitude of arrival. Okay, longitude or whatever. So this one answer already, and then to find the final cos. Okay. Okay. The final cos basically is this picture now. Final cos. Okay. Final cos this one. So in terms of picture, what is how it look like? Huh? So I will just continue to draw this picture here. The ship go from A to B and continue, right? Right? The ship go from A to B continues, and this is the toward North Pole. So the final cos is actually this angle from the North Pole continue this final cos. Okay. The rest is just followed by the big circle. Okay. So let's see how to find the final cos. Basically, you need to find angle B. Okay. What is this angle B here? So I can copy this page here and then continue. Okay, go to the next page. Okay, I now find the final cos now. So let me erase this part here. Okay, so to find a final cos, you can also use do you know the angle A? You don't know, right? You don't know. So yeah, you can actually use the sine law to find angle B. Okay, but disadvantage of using sine law afterward, then you have to see which is correct answer. So we are going to use the cosine law straight away. Okay, so we don't need to figure out which is the correct answer. Yeah, because cosine law only give you one correct answer. So I want to find angle B now. So let's write down and find angle B. Then afterward, then I can find out where is the final cos. Angle B is this one. Okay, so you can use the cosine law now. So I can use cosine of side B now equal to cosine of side A cosine of side P. Okay, P is actually, we figure out, is 46 degrees 24 minutes. Okay, same as angle P. And this one plus sine of A sine of P, then cosine of angle B. And we are asked to find the cosine angle B now. So put in the value, but before we do that, let's arrangement. So cosine B minus cosine A cosine P over sine A sine P equal to cosine B. So put in the limit, the value here, cosine B is 65 degrees, so 65 degrees minus cosine A is 32 degree. Then cosine P is 46 degrees, 24 minutes, over sine A, 32 degrees, sine P is 46 degrees, 24 minutes, and this will give you cosine of B. Okay, so press calculator, you get cosine of B equal to minus 0.42270122. So B is actually cosine inverse of the answer is 115 degree. Okay, this is actually quite a big angle here for 115 degree, more than 90 degree. So then what is the bearing final cost now? Okay, great circle cost at B now. Okay, great circle cost at B. Where is it equal to now? So if you know that B is 115 degree, so and this is actually great circle, right? Great circle is like a straight line. Okay, great circle is like a straight line. If you draw it like this, so just follow it the direction. This is actually like a straight line. So the basically great circle, anything move in great circle is behave like a straight line. Okay, so the angle theta is actually 115 degree plus 180 degree. Okay, because this angle looks like a straight line. Okay, 180 it looks like a straight line. So that's why plus 180, because moving along great circles it's just moving along a straight line, so angle of straight line is 180. So this is equal to 295 degree. Okay, this is the great circle, the cost, the final cost, theta here. Okay, the diagram may not be very accurate, actually. Okay, so the final cost actually this one, right? Okay, so that finished the example 11. That is the last example already. I don't intend to go to 12. Okay, so example 10 is a very important example. example 11 illustrate to you how to do this type of question again. Okay, so last few minutes to settle this. Okay, I think there are some people missing. Yeah, now currently only 17 people missing. Okay, Google, are you here? Google, are you here? No, Safikwa, are you here? Okay, Google, I know Safikwa, are you here?
Sure.
Yes.
Can I ask you one question?
Yes.
For the cosine B, right? How you get 115 degree?
Okay, how to call 115 degree? This one. Okay, cosine B, right? You press calculator minus 0.422. Okay, so minus 0.422, right? Then you find that what cosine inverse. So you have to calculate this one cosine inverse. So I just press my calculate cosine, C cosine inverse. Okay, C cosine inverse, then minus 0.4227, 0.00122. Okay, so I think I will get internal degree mode. So degree mode. So number 2 here. Then you get 115 degree.
Oh,
You
okay,
get this?
yeah, I get
Yeah.
it.
Yeah. That's how you get 115 degree. So I can stop recording already.